That look good? Yes, that looks good. All right. Yep. All right. I don't know if I know Alejandro, but anyway, my name is Mark Royer. I'm a PhD candidate in computer science at the University of Maine. What I'm going to talk about tonight is the Java 8 Stream API, and I'm going to give lots of examples of how that's used, or at least some examples. So when I was putting these slides together, I actually was a little bit worried because I told Isaac that I was going to talk about the Stream API in Java, but I didn't really clarify that I was going to be talking about the Java 8, the functional Stream API. So I won't be talking about the input-output Stream API tonight. I'm just going to be talking about the functional API that they placed on top of the collection classes in Java. So the Stream API that I'm talking about tonight is the one that you'll find in the Java util package. So the Java 8 Stream API, what it is it's a library that allows you to access a sequence of elements. And these elements are either calculated or retrieved on demand from typically arrays or collections from the collections API in Java, and sometimes it's I/O. And they have the typical aggregate operators that you'd find in functional languages, such as filter, map, limit, reduce, those type of things. I'll do some examples of that if you're not familiar with that. And the way that they've designed the Stream API in Java is that it uses pipelining, which means that as you do intermediate operations on the Stream objects, they return Stream objects that can be operated on. So I'm just going to start doing some examples. I have about 10 examples that I'll walk through. And I'm going to start with what we used in Java prior to the Java Stream API, and kind of show the progression of how we got to the Java, how and why the Java Stream API is something that you might want to use. So here is older Java pre-Java 5. And what I'm going to do is, actually going to go, can I mark the screen?
Let me see.
Or
bottom, maybe. Oops. Oops. Where's the zoom thing? This zoom? Oh. I don't know.
Oh, hi.
Yeah, I don't know.
All right, oh, here it is. Well, maybe I can use this. Oh.
There's something in the I know that I remember seeing the way to do it, but I can't remember.
Well, if you can see my mouse, hopefully that's good enough.
Oh wait, you go to view options at the top.
View options at the top. And annotate. Oh, excellent.
Yeah.
All right. So, so you need a source to be able to iterate over. So in this example, we're just creating a standard single dimension array in Java. And then pre-Java 5.0, the only option for iterating over that array was you use either some kind of loop, for loop or while loop. And you have an incrementer, and you just step one by one over the elements in that array. And so if we ran this little example here, it would just print out all the elements that are in this top array, which are 1, 2, 3, 4, and 5. Okay. And I also apologize if I know this is the Python group, so this is all Java code, and hopefully it's not too much to grok, but we'll see. Okay. All right. So clear. Okay. So the other option pre-Java 5.0 was that if you had an array and you wanted to iterate over it, you could convert that array using the arrays class to a list, and a list is iterable, so you could get an iterator, and you could use that to get the next element in the list, and while it had another element, you could continue iterating through and print out the result. And it would print out the same thing. So what are the things that are different between this and the other way? Well, if you were going to use an iterator, then you had to use the object type of double instead of double. So I didn't show it here, but the array initialization, this is of object type double instead of the primitive type double. And then we use the arrays as list to actually make the array class iterable. So those are kind of the two Java 5, pre-Java 5.0 ways of doing it. So up at the top here, I have the original way, just standard iteration. And then at the bottom here, what they figured out is that the iterating way was a very bulky way of iterating through something that's iterable. So they decided to introduce the for each loop, which is, if you look at the bytecode from the compiled code, this for each loop looks identical to that iterable stuff from the previous slide. But it's just a lot more condensed, and it is easier to read. So just for every double in that array, we're just going to print out the results. So that was a really good improvement that they added. So clear that, and we'll go to the next one. So then in Java 8, they introduced the Stream API, and we can achieve the same thing that from the previous slide, which is this for each loop, using the Stream API. So it's a little bit different, and I'll go through some more examples of how it works. But basically what it is we take that array that we had initially, and we pass it to this function in the arrays class called stream. That's this function here. And it returns a stream object. And this particular stream, there are a bunch of these stream constructors, but this particular one, because I passed it a double array, it returns a double stream. And it has functions that let us perform operations on the stream. And one of them is for each, and another, which is which takes a function and a for each ordered, which also takes a function. And they apply this function that's passed in to each element in that array. And the difference between the for each and the for each ordered is that if you call the for each method instead of the for each order, then it will happen in parallel, and you're not guaranteed that things will happen sequentially. So running this bit of code here actually produces the same output as the previous slide. So what were the notes that we came away from this? A double stream object is created from the array. That was this part. You would think that the double objects are boxed into their object type, but they're not for the Stream API. They're actually they remain as primitive doubles. And then the for each ordered function is what's called a terminal operation, which means that it doesn't return a stream object. So it's the last thing that you can call when you're manipulating streams. It's the end of the line. So that makes sense, terminal operation. And then this weird syntax for people that usually write C# or Java or that type of code, it looks almost like C++, like scoping code. This is saying we're passing in the method print line from this object. System is a class, .out is an object in the system class. It's the output stream. And it has a method called printline, and that's what we're passing into each ordered. So that's what's going on there. All right. So what is the change in Java that made it possible? So Java is an object-oriented language, which means that objects are first-class citizens of the language. And functions are not first-class citizens. So it means that it's a Turing-complete language. So it means you can calculate anything that's Turing, that any other Turing-complete language can do. But it just means that you have to work a little bit harder to be able to get the function to perform calculations in a functional manner. You have to work a little bit harder, or you had to prior to Java 8. And so an example of how this would work prior to Java 8 is if you wanted to create a function, you would create an interface. So here I'm creating an interface called function. And this particular interface, and this is kind of the way that they implemented it in Java 8, is a generic interface. So I apologize if you guys aren't used to working with generics, but basically all it says is we're going to have a single function, and I'm specifying the type here. It takes a single parameter and it returns a result. And the generic part here says the type of the parameter, we're going to specify that. We don't know what it is right now, but we'll specify that. So that's what the T placeholder is. And R is going to be the type of the result. Again, we haven't specified this. So this is how you would do this in pre-Java 8. So you create a function interface, and you use generics to specify the parameter and the result types. And so what would that look like? So, all right, so I'm just going to focus on the very bottom of this slide. So again, I apologize, this is a lot of code to look at, but again, I'm talking about the API and how this code works. So if you have any questions, just interrupt and I'll stop or slow down or whatever. But hopefully I'm stepping through it, and we can always come back to things too, if you think of it. So there was that function interface, and it was generic. So it took a type as a parameter for the function, and a type for the result. So we've specified double, double, and here's the actual function. So it took a double, so it's going to take a double as a type, and it's going to return a double. And then I'm actually defining the function here. So I'm just going to take the type that's the object that's passed in, and I'm going to multiply it by itself and return it. Okay, so because I can't access a function directly, what I do is I create an interface, and then I have classes. Java is object-oriented, and classes we create objects of, and those objects give us an indirect reference to the functions. So so the way that we do that is that, say we have some function, again, this is a generic function, but say we want to specify some function, and this particular function called concat, it's going to take a function that we don't know what that function is. So this is just taking some function, but there is one constraint, which is that it has to implement the function class that we specified on the previous slide, which is it has to take one parameter and return a result. So here we're taking concat, we're gonna take that function, and basically what this concatenation function is going to do is it's gonna take this parameter, it's gonna pass it to the function that we pass in, and then the result of the function is just gonna concatenate the two results together. So it's kind of a weird function, but fairly simple too. Okay, so then up at the very top here, we're gonna print out the concatenation function, which is the one that we specified down here. And here we're passing in, instead of passing in a function, we're passing in an object of square, which implements that function. And that function will actually get called inside of the concat function. So the result of this whole rigmarole, it seems like a lot, is it's going to take 5, it's going to pass it to this function square. 5 times 5 is 25, and that's called twice. So 25 is going to be concatenated to 25. So it'll be 25 concatenated with 25, not even added because they're strings. But so what does that bias? It makes it so that way the concatenation function, in this case, it's concatenating the square, but we could define another class, maybe called double or something, like double value, which instead of multiplied the value by 2 and then concatenated them. So you can get some different expressions, calculations from the same functions. So it's just a way of generalizing things. Okay, so then Java 8, they introduced lambda expressions. And what it meant is that we no longer have to implement this class down here, the square class. Instead, what we can do is we can just use a shorthand here to say, I'm going to just define a function that takes an object and multiplies the values and returns that. So it saves us, we don't have to create the interface, we don't have to create the class, we just can pass in this function. And this will produce the same output as the previous slide, which is the 25, 5 times 5 concatenated with itself, which is 25. So the important thing is that it makes it so we don't have to create a new class or the interface. But what we need to recognize is that they didn't make, when you compile down this code, it's going to be creating anonymous interfaces and classes that are going to, that will actually be executed on the JVM. So the same thing is actually happening on the JVM. And alternatively, instead of using the lambda expression, they also introduced these, what they call method references. So, and we used it for the system.out print line in the very first slide. And what this means is that instead of passing in the lambda expression, we're saying we'll pass in this function here, which I've defined down below, called M. This current class is called main. This function is basically matches the same method signature, and so it will work. And the last thing I need to say is I created this function interface, and to make everything work in Java 8, they created a very similar function interface that takes one parameter and returns a result. And so that's how those things work. So the reason why I mentioned the lambda expressions is because the Stream API does not work if we cannot reference functions and pass functions around um, I and I it would I should qualify that a little bit. It would still work. It's just that people wouldn't use it because it would just require so much. Java is already a very verbose language compared to a lot of the other popular scripting languages like JavaScript or Python. And if they didn't introduce the Lambda expressions, then it would just even get more verbose. Okay, so let's look at an example of what the Stream API actually looks like. So here's an example of taking the double array that we had before and converting it into a list using the arrays class as list method. And so we have a double list, and every collection class in the Java API, in Java 8, they introduced a method called stream. And so that converts it into a stream object. And once it's a stream object, then it allows us to have some of it allows us to have the typical functional methods that we would have in the functional paradigm. So for instance, map. So in this example, what we're going to do is we're going to take the list of double elements, and the map function, what it does is it takes a function. So we use Lambda expression for that. And what it says is every element in this stream, what we defined it as is we're going to multiply it by 2. So basically, we're taking every element in the stream and converting it into 2, 4, 6, 8, 10. And because this is a non-terminal operator, it returns a stream object, and we can further operate on that stream object. And so we're going to apply a filter method to that. And filter methods also take function expressions or Lambda expressions. The difference is that filter expressions, they have to take special function, which returns a Boolean operator, true or false. So here for every element in the stream, we're going to remove that element if it is not true. In other words, if it's not less than 10. So we already said this is going to become 2, 4, 6, 8, 10. So it's going to just drop the last element here, which became 10, and the output's going to be 2, 4, 6, and 8. The very last part, so this is quite a few examples. So there are a lot of different functions in the Stream API. So there's functions like map, there are things like filter. The question is that the result of filter, though, is a stream object. And most Java APIs still work with the collections classes. So those are things like collection, set, list, map, those types of objects. So after you're done with your stream object, how do you convert it back into a collections object? Well, what they introduced is this collect method. So the stream objects have collect methods. And what you do is you pass a function, and it's a function that given a stream can convert that stream to a specific type of collection. So, and they already created a bunch of the typical ones that we want. So they put them inside of this collectors class, and there are different ones. So toList or toSet or things like that. And a common one is toList, and it's a function. If you actually look at it, it's a function that's passed to this. And it's a function that knows how to convert this stream back into a list. And so that's what's returned from this, this collector here. This call to collect returns the list. And this is the output. Okay. So map, filter, collect. They also introduced some nice things like summary statistics for streams. So again, if you have your double array and you create a stream from it using the arrays class, you can call summary statistics, and it'll create a summary statistics object for you. And you can call things like get max, get min, get max, sum, average, count, other things like that, and it produces this type of output. So those are just a couple of examples of how the Stream API works. There's a whole bunch of different ways that you can use it. The important thing to note, and I'm going to wrap up here, but the thing that you need to remember is that streams are non-mutable objects. So the streams that return new streams, those are actually new streams, and the underlying stream, the previous stream objects, those are exactly the same. So if you have multiple references to those streams, you're not going to screw up your program at all. So that's a really nice feature. If you're doing parallel programming, again, you're not going to screw up your other threads because those are non-mutable objects. All of this functional programming notions came out of the functional programming paradigm. If you look at languages like Haskell, you're going to see this type of stuff everywhere. That's what it is basically all of. It uses lambda expressions, and we looked at that, I think, quite a bit. And most of where you're going to use this is iterating over either arrays or objects that are in the collections API. So that's pretty much all I wanted to share tonight. I don't know if you guys have any questions. Or...
I think you did have Alejandro had a question.
Oh, okay. All right. Is that at the top? Where's that? All right.
Okay. So, yeah, I don't think you heard that. So if you just want to repeat that.
Yeah. So you can definitely iterate over text. And what I was thinking of, well, I'm thinking of files specifically. They added in the files API, they added a streaming mechanism, so that way you can process files line by line. So, you know, if you were working with a text file, then that's something that you may want to look at.
Okay. So, do you have anything else, or that was?
Yeah, that's pretty much all I.
Okay, I'll come. Okay, so yeah, that basically concludes our meetup. If anyone has any more questions about PyData or anything like that, feel free to ask. Otherwise, I'm going to end this meeting. Okay, well, it was great, you know, seeing you here, Alejandro. I think you're the only one on Zoom. Wish more people had come out in person tonight, but I guess it was snowing really hard up here. So yeah, I hope to see you again on Zoom. And yeah, thanks Mark for doing the presentation.